Bismillahirrahmanirrahim. 7.3 Inverse of a matrix. Here this is the objective. Here we have to find the inverse by using AB equals to KI. This one is the properties method. Okay, second, using a joint matrix. Okay, so we have two methods to obtain the inverse of the matrix. First, by using a joint method, inverse equal to 1 over determinant A times adjoint A. So where this adjoint is equal to C transpose. And second, by using the properties AB equal to KI, where I is the identity. So let's find the inverse by using adjoint method. Okay, this is the formula that I showed you just now. And you have to remember that A power by negative 1, this one is the symbol of A inverse, not 1 over A. Because this one is not index, this one is a matrix. Okay, you have to take note about these things. When determinant is equal to 0, means that matrix is a non-singular matrix. Therefore, the inverse of that matrix is exists. And what happens when determinant equal to 0? So A is a singular matrix. The matrix become a singular matrix, and the inverse for this matrix is does not exist. Inverse of a 2 by 2 matrix. Okay, to find the inverse for 2 by 2 matrix, okay, we use the adjoint method. Okay, this is the formula of adjoint method. 1 over determinant AD minus BC. The AD minus BC, this one is a determinant, and this one is the adjoint matrix. So, as we already know just now, determinant must be not equal to 0. So if we have AD minus BC equal to 0, so the matrix has no inverse. Okay, so example 1, find the inverse of A, 3, 1, 5, 4. Okay, so this is the determinant, how to find it. Okay, this is the determinant. The downward minus upward. So we have 3 times 2, we have 12 minus 5 minus 1. So 5, so the determinant is 7. So we can proceed with the inverse. So if this one 0, the matrix has no inverse. So the adjoint by changing the place of 4 and 3, and then just change the sign of 1 and 5. So we have the adjoint matrix. Okay, so next, so our inverse is equal to this matrix, 1 over 7 over the adjoint. Okay, the adjoint, and then just multiply 1, 4, negative 1, negative 5, and 3 with the scalar here. So we have the inverse of matrix. Okay, example 2. Find the inverse matrix for the following matrices. Okay, I will show you just 2 of them. Okay, questions. First, we have matrix B, 3, 4, 5, and 2. So first step, you have to find the determinant. Okay, so the determinant is AD minus BC. So we have 3 times 4 minus 5 times 2. So what we have here is 12 minus 10. So we have 2. Since we have this not equal to 0, so we need to proceed with the adjoint matrix in order to get the inverse. So the adjoint matrix of B is equal to, by changing the place of 3 and 4, so we have 4, 3, and this one is negative 5 and negative 2. This is the adjoint matrix. Okay, so next, proceed with the inverse. Is 1 over determinant. Okay, this is our determinant just now, and multiply with the adjoint matrix. So we have 4, negative 5, negative 2, and 3, and then just multiply the adjoint with the coefficient here. So we have 2, negative 5 over 2, negative 1, and 3 over 2. This is the inverse of B. Okay, now how about C? Okay, same thing. The first one we have to find the determinant, whether the inverse is exists or not, depend on the value of determinant. Okay, so downward minus upward arrow. So we have 1 times negative 2 minus 3 times negative 2. Okay, so therefore we have 4. Okay, we have 4 here. Okay, next, proceed with the adjoint of C, adjoint matrix. Okay, by changing the place of 1 and negative 2, and by changing the sign of these two numbers, negative 3 and 2. Okay, so our inverse matrix is 1 over determinant, okay, times this adjoint matrix, negative 2, negative 3, 2, and 1. Okay, so just multiply it, the adjoint with the constant here. So negative 1 over 2, negative 3 over 2, so we have 1 over 2 and 1 over 4. Find the inverse of matrix A, and hence find the matrices B and C. Okay, from the given questions A and B. Okay, so first step we have to find the inverse of matrix A. In order to find it, we need to find the determinant in order to know whether the inverse exists or not. Okay, the formula in order to find the determinant is AD minus BC. So AD downward, BC upward arrow. So we have 2 times 3 minus 4 times 1. So we have 2. Okay, so now we have this determinant. So we can proceed with the adjoint. Okay, in order to get the adjoint matrix of A, okay, so we need to make interchange between E and D locations. E and D. Interchange that 2 and 3. 3 and 2. And then for C and B, just change the sign. So negative 1 and negative 4. Okay, so we can proceed with the inverse by using the adjoint formula. 1 over determinant times adjoint matrix or cofactor transpose. So we have 3, negative 1, negative 4, and 2. So now we have the inverse for this matrix is a 3 over 2, negative 1 over 2, negative 2, and 1. Okay, after we already get the inverse of A, so we can proceed with question B. and C. Okay, so we know this one is B. This one is a matrix A equals to, let's say this one is the answer. Okay, so we have 10, 10, 6, and 7. Okay, we need to eliminate this A from the left hand sided. Only its inverse can eliminate this matrix A. So it means that in order to eliminate A from the left hand sided, we need to multiply with A inverse. So if the left hand sided, we multiply with A inverse on the right hand sided of A, means that this one right hand sided should be multiplied on the right hand sided after the matrix, not on the left, on the right, because this one is on the right. Okay, so 10, 10, 6, and 7. So this one we change with the matrix just now. Okay, B, A times A inverse is identity. Okay, so right hand sided. So this one we change with the inverse, it inverse. So we can use the answer of the inverse, or maybe we can use that in the form of scalar. Okay, 1/2. We have 3, -1, -4, and 2. Okay, B times identity is equal to B. Okay, so we can multiply these two matrix. So this is the coefficient scalar, so we can put in front of the multiplication operations. So we can make the priority of the operations between the two matrix before we multiply with the scalar. Okay, 10, we have 10, we have 6, 7. So we have 3, -4, -1, and 2. Okay, B is given by 1/2. Okay, the multiplications between these two matrices. Okay, by applying the dot product, row times column. Okay, so we have 10 times 3 plus 6 times -4. So we have 6. 10 times -1 plus 6 times 2. Okay, so we have 2. Okay, next for the entry for the second row, 10 times 3 plus 7 times -2. So we have 2. Okay, next the last entries, 10 times 1, 7 times 2. So just edit. Okay, 4. And then multiply with this scalar. So we have 3, 1, 1, and 2. B, in order to find the matrix C. So now the difference between equation A and B is the locations of matrix A. Matrix equation A is on the right of B. Okay, matrix B, question B, A is on the left hand side of matrix C. Okay, this one is matrix A, this one is C. Okay, 10, 10, 6, 7. Okay, so left hand sided, you have to eliminate A from the left hand sided. only its inverse can eliminate such shared matrix. Okay, so negative A times A C equals to, okay, due to we multiply A inverse on the left hand side of A, means that this side also must be in the left of this matrix. Okay, 10, 10, 6, 7. A inverse times A is identity. Okay, the inverse is 1 over 2 times 3, negative 1, negative 4, and 2. Okay, then multiply with this matrix. 10, 10, 6, 7. Okay, ID times C is C. 1 over 2 is a constant, so we have to proceed with the multiplication between two matrices. 3 times 10 plus negative 1 times 10. Okay, so we have 20. 3 times 6 plus negative 1 times 7. So we have 11. Negative 4 times 10 plus 2 times 10. So we have negative 20. Negative 4 times 6 plus 2 times 7. Okay, what we have here? We have 10, negative 10. Okay, next. Okay, just multiply with the scalar. So we have 10, 11 over 2, negative 10, negative 5. This is the answer of matrix C. Okay, let's go how to find the inverse of a 3 by 3 matrix. So we have to know how to find the adjoint matrix for the 3 by 3 before we proceed with the inverse. Okay, let C is the cofactor matrix of A, so the adjoint is the transpose of C matrix or cofactor matrix. Okay, adjoint is equal to C transpose. Okay, you have to remember how to find the cofactor matrix. Still remember about this. Okay, this cofactor matrix, the entries. Okay, example 4. Given A is this 3 by 3 matrix, find the adjoint of A. Okay, in order to find the adjoint, you have to remember about these two things: the cofactor matrix. Okay, so we have 5 members because of 3 by 3 matrix. So you have to find C11, C12, C13, C21, 22, 23, C31, 32, and C33. Okay, in order to find the C1, you have to remember the sign and also the minor. The minor, you have to delete the first row and first column, then proceed with the determinant of that one. Okay, this is the matrix. Okay, this is the sign. The sign is positive. Then from the matrix A, by deleting the first row and the first column, the remainder of the matrix is 2, 4, 1, 3, and then find the determinant of that remaining. Okay, we have negative 2. Okay, C12. Okay, the sign. So means that we have to delete the first row and second column. The sign is negative here. Okay, the sign is negative. Okay, that's why we have to put negative here. And then this is the minus. So we have negative 5. 9, 3 times 3 minus 1 times 4. So we have negative 5. C13 by deleting the first row and third column. So the remaining entries is 3, 2, 1, 1. So you have to find the determinant for that remaining. Here the sign is positive. Okay, should be positive here. If you don't know why I write it one, it's not a big problem. Okay, so 3 times 1 minus 1 times 2. So we have 1. 3 C21. Deleting second row and first column. The remaining entry is 2313. Okay, the sign from this one is negative. That's why we have to put negative here. Okay, multiply this two things minus upward arrow. So we have negative 3. 6 minus 3. So we have negative 3. Okay, then for C22, by deleting second row and second column, the sign that we have is positive here. So if you want to put negative, positive also can, no problem. Okay, so down arrow minus upward arrow. So we have 3 minus 3. So we have a 0. Okay, next C23 by deleting second row, third column. Okay, the signage is for a negative here. So we have to put negative in front of the determinant. Same as before. 1 times 1 minus 1 times 2. So we have 1. Okay, C31. By deleting the third row, first column, the signage that we have is positive. Okay, so positive here. So we have 2 times 4 minus 2 times 3. So we have 2. So C32, eliminate the third row, second column. Okay, so the remaining numbers or entries 1, 3, 3, 4. Okay, so we have 5. C33, eliminating the third row, third column. So we have negative 4. The cofactor matrix is given by 2, negative 5, 1, negative 3, 0, 1, 2, 5, and negative 4. Okay, so in order to get the adjoint, we just make a transfer positions of that cofactor matrix. So inside this is the cofactor. Just make the transposition operation so we can get the adjoint of that matrix. Example 5. Given P is this matrix, find the adjoint of P. Okay, so we have the solution for this. As before, we forget about this, the signage of cofactor. We have plus, minus, plus, negative, positive, and negative, positive, negative, and positive. Okay, so this is the cofactor. So all of this we can get by eliminating certain row and column from matrix P. Okay, for example, the first entries 1 1, there we have to delete the first row and first column from P matrix. So the remaining is 10 5 3 3. Okay, then find the determinant for the remaining. So signage positive due to this one positive, and then in order to get the determinant AD minus BC, so we have 15. Okay, then for the second entries 1 2, eliminating the first row second column, and then the signage, don't forget about this one, the signage negative. And then by finding the determinant from this remaining AD minus BC, AD minus BC. Okay, so we have -1, similar as with the others. Entries 1 3, eliminate first row third column, remaining is 2 10 1 3. Signage positive, similar as this one. And then finding the determinant AD minus BC, 2 times 6 minus 1 times 10, so we have -4. Okay, so second row 2 1, remaining 2 2 3 3, so we have identical entries here, 2 3 and 2 3 identical, so according to properties must be 0. Okay, and next second row second column, so positive here, similar as this one. Okay, by deleting second row second column, the remaining is 1 2 3 1 3. Okay, so and then the determinant 1 times 3 minus 1 minus times 2, so we have 1. Okay, next 2 3, so negative sign, eliminating the second row third column, the remaining is 1 2 1 3. Okay, same as this one, so should be, so have -1 due to negative sign here. And then the last row, third row first column 3 1, eliminate the third row first column, remaining is 2 2 10 5, sign is positive, and then the determinant AD minus BC, so you have 10 minus 20. Okay, next signage is negative sign, by deleting third row second column, so remaining is 1 2 2 5, and then find the determinant for this remaining, -1. And the last one C3 3, eliminating or deleting third row third column, so 1 2 2 10, so we have 6. Okay, from there this is our cofactor. Okay, after we have the cofactor, we can proceed with the determinant, the inverse, if you want. Okay, this is our cofactor, and then the adjoint, we have to make a transposition operation of the cofactor. So this is our adjoint. Example 6. Given A, find A inverse. In order to find the inverse, we have to decide which row or column that we want to use. Okay, for example, in this solution, I choose to use the first column. Okay, the entries of the first column is A11, A21, A31. Where the entry is 1, 3, and 1. So we have to find the corresponding cofactor for all these entries. So we have to find cofactor of C11, C to 1 and also C 3 1. Okay, so in order to find the cofactor C11, you have to remember which row or column that has B to delete. Okay, so C11 is that we have to delete the first row and first column. So the remaining entry is 2, 4, 1, 3. Okay, so in order to find the value of cofactor C11, you have to use this one. 2 times 3 minus 1 times 4. So we have 6 minus 4. So we have 2. Yes, same thing with C to 1. Okay, the sign is negative, and then by deleting the second row and first column, so the remaining entries is 2, 3, 1, 3. Okay, 2 times 3 minus 1 times 3, so we have 6 minus 3. Okay, so we have the negative sign in front of this one. Okay, so we have negative 3. And then for C31, by deleting the third row and first column, so the sign from this is positive. So 2 times 8 minus 2 times 3. So we have 8 minus 6, that is 2. So this is our cofactor entries corresponding with the selected column. Okay, in order to find the determinant, by multiplying A and C, and then total up. Okay, this way 1 times 2 plus 3 times negative 3 plus 1 times 2. So we have total up, we have negative 5. That is the determinant. And then in order to find the inverse, we need to find the rest of the cofactor entries. Okay, we already have 3 of them just now, and then proceed with the others. Okay, so this is the way, this is the method, by deleting certain row and certain column. For example, C11. Okay, the positive sign here. Okay, due to positive sign here. And then the value. Okay, this one minus this red. Which one? So we have 2. C12. Taking first and second column. So we have these things. So we have the answer is negative 5. C13, deleting first column and third row. Sorry, by deleting the first row and third column. So the remaining is 3, 2 and 1, 1. So the sign in front of this is positive. Okay, according to these signs. Okay, in order to find the value, downward minus upward arrow. So we have 3 minus 2, so we have 1. And similar with the others. C21, delete the second row, first column. Okay, the sign here is positive, similar as this one. Sorry, negative, not positive. Okay, same method, downward minus upward arrow. So we have 6 minus 3, so we have negative 3. C22, delete second row, second column. So the sign in front there should be positive. Okay, so we have 0, C to 3. Okay, negative sign here, exactly same as the signage that you have to remember. Okay, this one. Okay, and then so we get 1, 31. Okay, in third row, first column. Remaining is 2, 3 to 4. Okay, the sign should be positive here. Okay, as before, 2 times 4 minus 2 times 3. So we have 2. Okay, see 3 to the third row, second column. Okay, so we have 5. C33, the third row and third column. So we have negative 4. Okay, so this is our cofactor matrix. This is the value that we get from our cofactor entries just now. Okay, this is our cofactor matrix. In order to find the adjoint, just make some transposition operations for this cofactor matrix. Okay, this is our adjoint matrix for matrix A. And for the inverse, just substitute in our inverse formula, A over determinant times adjoint A. So we have this is our inverse of A. Okay, example 7. Find the inverse of B. Same method using the first column. You can choose any column, but our priority choose the most 0 entries. So we can choose, we have 2 0 there, so you can choose which one that you like. Here this is our entries from the second column, B11, B21 and B31. So as before, find the corresponding cofactor entries. C11, C31. Okay, C21, no need to find it because our entries for 21 is 0. So if you find it, then multiply by 0. So result should be 0. So need to find for C21 in order for determinant. Okay, but for the cofactor, you still have to find it in order to find the adjoint matrix. Okay, this is the signage that you have to remember in order to make it easier for our calculations. Okay, C11, C12, so by deleting the row and certain column suitable with our positions of the entry. So this one signage positive. If you don't want to write the signs, also no problem because not affected with the signage. Positive for these things and also positive. Okay, this is our cofactor, and then you need to calculate in order to find the entries. So for this one we get 2, negative 4 for the second row, fourth row, and the result for our cofactor matrix of B is this one. Okay. Here this is our adjoint matrix by making the transposition operation of the cofactor matrix.